Okay, students, this is 6.6b as you see here. This is your second inequality sheet for the week to do. There's only two, these two plus the ones you didn't do from 2 weeks ago. So you've got basically 2 weeks worth of material for most of you to do. So this one, not only are we solving it, but then we're going to graph it on a number line afterwards. So we solve it the exact same way, and then we just put our answers on the number line afterwards here. Okay, so I'll do two of these here. Let's say number 7. Let me write this down here. You notice there's only 12, so I'm just going to do 2. Okay. Absolute value negative x minus 5 is, so now these are absolute value inequalities. Notice the last sheet was absolute value equalities or equations. Okay. That's why we're going to have an infinite amount of answers shaded in between two numbers here. Okay, so we see that, oops, did I copy down the right one? Let's see, 7, yeah, less than 1. Okay. All right. Let's get to right here. There we go. There's the problem right there. Again, we're going to have two inequalities that we're going to solve. We first get the absolute value by itself, which it already is. So the first one, all I do is take off the absolute value, and now I solve it. Now, remember what I suggested, if the variable you solve for, if the coefficient is negative, to move it to the other side. So that way you're never going to be divided by a negative, which now means the constant is going to come across here. So I'm adding this across, and I am subtracting 1 across. What's negative 5 minus 1? Negative 6. Okay? And then we usually like to read this from the variable side first. So x is greater than negative 6. You can also pronounce it negative 6 is less than x, but a lot of people have a harder time understanding what that means. It's easier for them to understand x greater than negative 6. So that's why I say most people will read it from the variable side first. All right, so that's the first one. Now the second one, this is I'm multiplying by negative 1. Remember, I'm taking the opposite. So multiplying by negative 1, I have to switch the inequality. So I have negative x minus 5 instead of less than is greater than negative 1. Again, that's because remember, if you recall the rule, if you ever multiply or divide by negative with inequality, we have to switch the inequality sign. So we are multiplying by negative, we're taking the opposite of the other side. Again, I'm in the same situation, so I'm going to add the x across here, and this time I'm going to be adding 1 across. So I have x is less than negative 5 plus 1 is negative 4. Okay, so I read that as x is less than negative 4, or I could say at negative 4 is greater than x. And again, most like to read it from the variable side. They understand it better. So we have x is greater than negative 6. So I'm going to number on here. 0, 1, 2, 3, 4, 5, 6. It's greater than negative 6. So since remember, there's no equal sign down here, that means it's going to be an open circle. So it's greater than negative 6. I have an open circle. If that had an equal sign down here, it'd be closed circle. It would include it. So it's greater than negative 6, where greater than is always to the right. And it's x is less than negative 4. There's negative 4. Again, no equal sign, so it's an open circle. And less than is to the left, so it's shaded right in between here. Any number between negative 4 and negative 6 will work. Make it true. So for example, negative 5. If you want to talk about integers, negative 5. What's negative of negative 5 is positive 5, right? The opposite of negative 5 is positive 5. Minus 5 is 0. Is 0, the absolute value 0 is 0. Is 0 less than 1? Yes, it is. Let's say somehow you thought you shaded on this side, and the answer you had shaded was negative 7. Well, if I plug negative 7 here, the opposite of negative 7 is positive 7. 7 minus 5 is 2. The absolute value of 2 is 2. Is 2 less than 1? No, that's false. So negative 7 would be wrong. Let's say you somehow thought it was shaded on this side. Let's say -3. So the opposite of -3 is +3. 3 minus 5 is -2. The absolute value of -2 is +2. And is 2 less than 1? No, it's not. So -3 is also false. So it's easy to tell where it needs to be shaded if you weren't sure on how to read these correctly. I could just take numbers, one on each outside, inside, and outside, and see which ones are true. And the ones that are true is where I shade. If it's false, I don't shade it there. Okay, let's go ahead and do one more. So let's say we'll take one down here, the fraction. Well, we'll say number 11. We'll write it down here. Absolute value of 1/2 x minus 4 is greater than 20. Okay, so I have it written down here now, right there. And now notice it's already got the absolute value by itself, so I can just write the first one by taking off the absolute value. And okay, here is another thing I forgot to say. See how this is less than? This is less than this. See how it has that than there? Just think of adding in a D, and. So this needs to be an and in between here. Okay, so x is greater than -6 and x is less than -4. On the other hand, this is the greater than symbol. So greater is spelled like this. But think of, instead of ER, just think of OR for greater. So this is an OR in between here. So just think greater. Instead of greater, just change an OR for greater, and then you know what to write down right there. It's less than, ends in AN, put a D on it for and. That's a simple way to remember if it's an and or an or. If it's an and, okay, it's going to be shaded in between two numbers. If it's an or, it's going to be shaded on the outside if you have two different numbers, or it could be the entire number line. Okay? So, just so you know that. So that'll help you as far as your graphing. But again, I can always just plug numbers in when I'm done on each side and see which ones work as well if I want to check. Okay, so the other one, 1/2 x minus 4. Remember, since we're multiplying by -1, I have to switch the inequality sign and make it -20. And then solve both those. Okay, we can solve them both at the same time. Reverse PEMDAS. Remember, add or subtract first, so we're adding the 4 across both sides. I get 1/2 x is greater than 24, or 1/2 x is less than -16. -20 plus 4 is -16. And what's the last step? How do I get rid of this 1/2? Divided by 1/2 is the same thing as multiplying by 2. Remember the reciprocal. So x is greater than 48. Or, again, I'm doing 2 again. X is less than -32. So it's either greater than 48 or less than -32. Okay? So now, when I'm talking about doing it on this number line here, I'm going to have numbers that are fairly decently apart. Ultimately, this is how I let you do it. I don't care if you have each one evenly spaced like this. This is what I'm going to let you do, because this is what I was allowed to do. The key is you understand it. I'm just going to put 0 here. I'm going to put a -32 here. And I'm going to put a 48 here on the number line. Okay, that's what I want to see. Again, no equal signs, so they're both going to have open circles there. X is greater than 48, or greater than is to the right. So I just want to see it shaded to the right with an arrow going on forever. Or X is less than -32, less than is to the left. Or I told you it goes to the outside. I'm talking about ors, unless it covers the entire number line. Okay, and there's your answer. So I'm not concerned that you figure out back on using this sheet here, oh, I got to figure out how many each space should be. I'm not concerned about that. I want you to know negative is to the left of 0, positive is to the right of 0, open circles, versus closed circles and shaded to the right or left. So I'm not concerned about, using these number lines here. You can just make up your own on your own paper if you wanted to, just like I've done here, on this sheet. I've done the whole thing on my own paper. So if you're doing that, that's fine. You don't have to take a screenshot of the main page at all because you've done it all right here. Okay? And you've got your number lines right here just so they need to be that I care to see. Okay? That will do it for this lesson.